chemistry lab that lots of organic compounds are placed in different bottles having their name written on them, and many of them even have same physical appearance, which surely made you think that how our lab assistant know which compound is which. He or she must be smart, no? Yes, our lab assistant is smart because he know how to do the systematic analysis of organic compounds. And believe me, within few moments you too are going to be as smart as your lab assistant. It is well said that chemistry is just like your life. You have to do analysis systematically to know about compounds, just like you have to do self-analysis to know yourself. So hi folks, my name is Gautam, and today me and my team members are going to present in front of you the systematic analysis of carboxylic acid, and step by step we together will identify which carboxylic acid it might be. So telling you about the work distribution, all four of us has collected the content. Mihir and I have prepared the slide of the presentation, and Chavi and Sumit are going to explain the same. Followed by Mihir, who will answer some of the follow-up questions related to this topic. In accomplishment of this presentation work, many people have owned upon their blessings. I, along with my team members, would like to thank respected Principal of Ramjas College, Dr. Manoj Kumar Khanna. A special thanks of gratitude to our organic chemistry practical teachers, Dr. Sonia Ratnani, Dr. ABHA Kathuria, and Dr. SARIKA Malik, for their valuable guidance, supervision, and support in completing our work successfully. It is because of their consistent efforts which encouraged us to work efficiently and to be more innovative, to inculcate new ideas, and to make this presentation more fruitful. Now, handing over to Sumit. Sumit, please continue with the presentation.
Thank you, Gautam. So, beginning from our main topic, that is qualitative analysis. So, after listening this term, the first question that arises in our mind is what it is basically all about. So, basically, qualitative analysis is a technique which is employed to characterize and identify organic compound. Now, as we all know that there are millions of organic compounds present on our nature earth, and henceforth it is a very big challenge in front of the scientists and the people to identify and characterize each one of them. And for that matter only, the qualitative analysis is used. So, qualitative analysis is a process used to determine and identify the unknown organic compound on the basis of their chemical properties and physical properties. Now comes the important part, that is systematic qualitative analysis. Basically, this technique can be divided into 6 steps. The very first one is the preliminary test. In this, we basically subject a compound, we see its color, its order, its nature. We subject it to the tests like solubility, like unsaturation, and like flame test. Then coming on to the second step, that is the extra element detection test. In this, we basically detect whether our compound has nitrogen, sulfur, halogen, etc. present in it or not. Then comes the third step, that is functional group identification. Now, as we all know how to identify a functional group like alcohol, carboxylic acid, amides, amines, and many more. Then comes the fourth step, that is the determination of a physical constants. It In this we basically determine the melting point and the boiling point of our compound with the help of Gelda's method, electric method, like that. Then comes the fifth step, that is the preparation of a suitable derivative. So, as per the suitability of the derivative and the nature of the derivative formed, we form a derivative of a compound. Then comes the sixth and the final step, that is the melting point of a derivative. Now, after following all these elementary 6 steps, we are able to know that which kind of a compound it is and basically what compound we have got. Now, beginning from the preliminary test. So, as it is the very first test, we firstly check the physical state of our compound. Now, in our case, the physical state is solid in nature and it infers that it may be a carboxylic acid, phenol, or a carbohydrate. Then comes the odor. Our compound has a faint odor. It clearly infers that alcohol, carbonyl, and esters may be absent in it. Then comes the color. Now, the compound has white color, or we can say it is a quite colorless compound, which infers that it may be a carboxylic acid, phenol, or a carbohydrate. Now comes the second test, that is the solubility test in the preliminary series. So, in this, we basically take a pinch of our organic compound and subject it to test the solubility in the following solvents. Now, the very first one, that is the water. Our compound is soluble in water, which infers that compound may belongs to lower member of functional group. Then comes the sodium hydroxide. Our compound is also soluble in sodium hydroxide. It infers that it either possesses phenol or a carboxylic acid group. Then comes the sodium bicarbonate. Now, sodium bicarbonate, our compound is soluble. and it clearly infers that compound possesses carboxylic acid functional group. Then comes the dilute HCl. In dilute HCl, our compound is insoluble. Henceforth, amine group is absent in it. Then comes the ethanol. Our compound is soluble in ethanol. Now comes a very important test, the third test in the preliminary series, that is the ignition test. Now, in this, we basically subject our organic compound to the flames. Now, please look into the first video. Now, as we can see, when we subject our organic compound to flame, then the nature of the vapors evolved are black in color. It infers that it has a more of a carbon content, henceforth giving the sooty flames. That's why it is an aromatic compound. Now, please observe the second video. Now in second video, as we can see that when we subject our organic compound to the flames, the nature of vapors evolved are white in color. It infers that the hydrogen content is more in it, and henceforth it is giving non-sooty flames and is a aliphatic compound. Now particularly talking about our compound, in this we have to firstly prolong it. We have to subject our compound to prolonged heating, and the observations were that it was giving non-sooty flames, and henceforth it was an aliphatic compound. Now comes the very important and the final stage of the preliminary test, that is the unsaturation test. Now basically unsaturation test is divided into two, that is the Bayer's test and the bromine solution test. Now firstly, beginning from Bayer's test, in this we take our organic compound and we subject it to the alkaline potassium permanganate, and as per the color change we decide that whether the compound will be saturated or unsaturated. Now please observe in the first video. Now as we take the test tube A, which contains an unknown organic compound, we subject it to the alkaline caminophore, and after shaking we can see that the decolorization is not taking place, and henceforth the compound is a saturated compound. But now see, we have taken another unknown organic compound in the test tube B. Now as we add alkaline caminophore in the test tube B, after shaking we can observe that the decolorization or a white color is coming up. It clearly infers that the unsaturation may be present or compound may possess oxidizable group like alcohol, carbonyl compounds, etc. Now, particularly talking about our case, the decolorization did took place, and henceforth it infers that unsaturation may be present or compound may possess oxidizable group like alcohol, carbonyl compounds, etc. Now, coming on to the second part of the unsaturation test, that is the bromine solution test. Now, please look into the video. Now, as you can see, when we take the test tube, when we take an unknown organic compound in the test tube A and subject it to the aqueous bromine water, then after shaking, we can see that there is no decolorization being taking place, and henceforth it is an saturated compound. Then comes the second test tube. Now in second test tube also we have taken an unknown organic compound different from the test tube A, different from the one being in the test tube A. Now as we can see, when the bromine water is being added to it and after few shaking in the test tube B, the white color appears, and henceforth the decolorization did took place, and it infers that unsaturation may be present or compound may possess phenolic or a aromatic amine group. Now, particularly talking about our case, firstly, after shaking, we also had to subject our compound to heating. Now, the observations were that the decolorization did took place, and it infers that unsaturation may be present or the compound may possess phenolic or aromatic amine group. Now, since the given organic compound responds to both Bayer's test and bromine solution test, so from these tests we can infer that unsaturation is present in the given organic compound. Now, I will request Chavi to please carry on.
In continuation with Sumit, the next step after preliminary test is extra element detection. Since our compound doesn't possess any extra element, so we say in inference that nitrogen, sulfur or halogen groups are absent. The third step is detection of functional group. So we start with carboxylic acid followed by alcohol, phenol, carbonyl compound and ester. For carboxylic acid, first of all we perform litmus test. Since carboxylic acid are well known for their strong acidic character, therefore the given sample, as you can see, turns the blue litmus red. In our case also, when we add the given solid compound in blue litmus solution, it turns its color to red. So we say in our inference that carboxylic acid group may be present, or there might be a possibility of phenols, since phenol also responds to litmus test. The next test is sodium bicarbonate test. For this, we add a pinch of sodium bicarbonate in the given aqueous solution, and there is a brisk effervescence of carbon dioxide which confirms the presence of carboxylic acid. In our case also, when we add a pinch of given solid compound in 2 ml of cold saturated solution of sodium bicarbonate, there is a brisk effervescence of CO2 observed. So we say in our inference that carboxylic acid group is confirmed. After this, we will do a test for presence of dicarboxylic acid group. So for this, we take equal amount of given acid with equal amount of resorcinol in a dry test tube, followed by addition of few drops of concentrated sulfuric acid, and then plunging the contents into a beaker containing dilute NaOH solution. Appearance of green fluorescence indicates the presence of dicarboxylic group. Here also there is a green fluorescence observed, so we say in our inference that dicarboxylic acid group is present. The fourth step is determination of physical constant. Being a solid compound, melting point of the compound is to be determined using either electrically heated melting point apparatus or Zeldal flask method. So we have melting point of our compound as 133 degrees Celsius. Till now, what we get to know is the given compound is solid, aliphatic 1, unsaturated dicarboxylic acid. So you all might have some possible names in your mind. So to confirm about the specific one, we proceed to our next very important step, that is preparation of derivative. For a dicarboxylic acid, anhydride is said to be the best derivative. But we generally don't prefer an anhydride derivative for the given compound. Why? You can see the melting point of the anhydride derivative, that is 52 degrees Celsius. It is not a property of a good derivative. A good derivative should have a sharp and discrete melting point so that its isolation would be easier. So we discard the preparation of anhydride, rather we prefer SBT derivative, that is S-benzyl isothiauranium salt. So for this we take 2 boiling tube. In boiling tube 1, we dissolve 1 gram of given acid in aqueous sodium bicarbonate solution until the effervescence of CO2 ceases. Simultaneously, in another boiling tube, we prepare a solution of 1 gram of S-benzyl isothiauranium hydrochloride in water. After that, we pour the contents of boiling tube 1 into boiling tube 2 and then stirring the resulting mixture thoroughly. After some time, salt starts separating out. We filter off the salts, recrystallize it with dilute ethanol and determine its melting point. So we have melting point of our derivative as 173 degrees Celsius. So when we check our experimental data with the literature value, we go to prepare a list of probable compounds. Generally, preparing a list of probable compounds is the step that is performed after detection of functional group. Preparation of derivative helps us in further elimination. So we have some probable compounds, namely maleic acid with melting point of 132 degrees Celsius and melting point of its SBT derivative as 173 degrees Celsius. The second compound is malonic acid with melting point of 135 degrees Celsius and melting point of its SBT derivative as 147 degrees Celsius. And the third one is cinnamic acid with melting point of 133 degrees Celsius and melting point of its SBT derivative as 175 degrees Celsius. But we know from our systematic analysis that the given compound is unsaturated and not the saturated one like malonic acid. And the given compound is aliphatic one and not the aromatic one as cinnamic acid. So we say in our result that the given organic compound was identified as maleic acid. Here are some reactions involved in the chemistry of maleic acid. First one is sodium bicarbonate test, where there is an evolution of CO2 gas along with the formation of sodium salt of malic acid. The third one is fluorescein test. Thereby we get a green fluorescence due to paraquinoid form. And here is the mechanism involved in the fluorescein test. The paraquinoid form is responsible for the green fluorescence due to extended conjugation. In the next slide, you will get the preparation of S-benzyl isothiauranium salt, for which we take benzyl chloride with isothiourea in presence of alcohol, which gives us S-benzyl isothiauranium hydrochloride salt. And here is the reaction involved in the S-benzyl isothiauranium derivative. Now over to Mihir for the questionnaire part.
Thank you, Chavi. And now I will be discussing some of the questions based on malic acid and qualitative systematic analysis. So here we go, and our first question is, what is the IUPAC name of malic acid? So the answer for this question is 2Z-but-2-ene-dioic acid is the IUPAC name of malic acid. Next question is, how will you distinguish between malic acid and fumaric acid? And the answer for this question is that in order to distinguish between malic acid and fumaric acid, we should determine their melting point, because fumaric acid has melting point 286 degrees Celsius and malic acid has melting point 135 degrees Celsius. As you can see the structure of malic acid and fumaric acid on the right side of the slide, you can observe that these are structural isomers of each other. That is, malic acid is cis isomer, whereas fumaric acid is trans isomer. Now, why trans isomer, that is fumaric acid, is having higher melting point than malic acid? This is because melting point of any compound depends on how closely the atoms are packed inside a crystal lattice. Since in case of fumaric acid, the two bulky carboxylic acid group are present opposite to each other, that is in trans position, so they pack more closely inside a crystal lattice and are more symmetrical. And hence, as a result, high amount of energy is required to melt these crystal lattice or to break these crystal lattice, and therefore they have higher melting point. On the other hand, malic acid having which is a cis isomer, is having two carboxylic acid bulky groups on the same side. As a result, they do not pack well inside a crystal lattice, and hence they have a lower melting point. Another method from which you can distinguish between fumaric acid and malic acid is by formation of their anhydride, because in this case only malic acid form anhydride, whereas fumaric acid don't form anhydride, because in case of malic acid the two carboxylic acid group are present on the same side, which leads to formation of anhydride. So the next question is, what are the uses of malic acid? And the answer for this question is that malic acid, first of all, can be used as a precursor for food additives. It can be used to make other chemicals, like it can be used to manufacture malic anhydride or fumaric acid and etc. And it can also be used for dyeing and finishing naturally occurring fibers. Let's come to our next question, that is, how will you distinguish between formic acid and oxalic acid? So the answer for this question is that in order to distinguish between formic acid and oxalic acid, we can do tolerance test, because formic acid gives positive tolerance test, whereas oxalic acid don't. Now a question may arise into your mind that formic acid possesses a carboxylic acid group, so why it gives tolerance test positive, which is for carbonyl compound? So the answer for this question is that formic acid is not much stable and therefore converts into formaldehyde to some extent. Also, if you see the structure of formic acid closely, you may observe that it has a COH group, that is, an aldehydic group is present in formic acid, which is responsible for giving positive tolerance test, whereas oxalic acid don't give positive tolerance test. Therefore, through this test, this formic acid and oxalic acid can be distinguished. The next question is that what is the product form when malic acid is heated at firstly around 50 to 60 degrees Celsius and secondly at a temperature greater than 200 degrees Celsius? So the answer for this question is that when malic acid is heated at a temperature 50 to 60 degrees Celsius, then malic anhydride product is formed. Whereas when malic acid is heated beyond 200 degrees Celsius, the product form is fumaric acid. Now, why these two products are being formed when malic acid is heated at different temperature? This is because what happens that when malic acid possesses a double bond, and we know that rotation around double bond is restricted because high amount of energy is required to rotate the bonds around the double bond. That is, they are having high energy barriers. But when these double bonds are broken, the rotation becomes easy and therefore malic acid can be converted into fumaric acid easily. And this is possible when the temperature is greater than 200 degrees Celsius, because at that temperature only enough energy is present in the system to break double bonds of malic acid to convert it into a free radical intermediate. And since free radical intermediate possesses a single bond, so the rotation around single bond is easy, and hence malic acid is converted into fumaric acid. And now these are the references that we have taken to make this presentation. Thank you for watching our presentation. I hope you like it. Thank you so much.